Welcome to We Are CASE, the podcast by the CASE Alumni Association, where we explore the stories of those who are thinking in the CASE tradition. From groundbreaking research to transformative careers, we feature the inspiring alumni, faculty, staff, and students of the CASE School of Engineering and Mathematics and Applied Sciences. Each episode dives deep into the journeys of those shaping the future, whether they're on campus, leading industries, or even redefining what it means to retire. It's all about innovation, perseverance, and the creative ways our community is making an impact. We Are CASE is produced by Abby Murphy, the Director of Digital Content and Design for the CASE Alumni Association, and hosted by Robert Smith, the Director of Communications for the CASE Alumni Association.
Hello, everybody, and welcome to another episode of We Are CASE. We are here today at Dory Power. It's a startup founded by CASE Professor Chris Yuan and powered by CASE talent like Ken Loparo. All right, everybody, we're excited to be here today with Ken Loparo, who you know as an esteemed professor at Case Western Reserve University, but who is also the chief scientist at Dory Power, a new startup that is going to change the portable generator game. Ken, thanks for being here and welcome to the show.
Of course, thanks, Bob. My pleasure.
So, tell our viewers, where are we and why you're excited to be here?
Okay, so we're at the corporate headquarters of Dory Power. Dory Power is as Bob mentioned, it's a company founded in 2017 and by Chris Yuan, who is actually a faculty member currently at Case Western Reserve University in the Department of Mechanical and Aerospace Engineering. And we're in the conference room at Dory Power, which is a 40,000 square foot facility in Euclid, Ohio, where the Dory Power portable electric generators are assembled.
Okay, and I'm looking at the generators here, and I'd say they're about the size of carry-on luggage.
They are.
They're portable.
They are.
They're compact. They're heavy. The big guy, which would be more like a medium-sized luggage, weighs 170 pounds.
That's correct.
And they're so heavy because?
Well, so there, in particular, there's the batteries that are in these units are compact. They're lithium-ion batteries, and a particular battery chemistry called LFP. And this technology, even though the individual cells are small, you integrate them into a battery pack, and they become pretty substantial from a weight perspective. And then, of course, you have all the electronics that are sort of connected to the batteries to help manage them, both in terms of their charging and discharging, but also the interface to the unit that allows the user to understand how the unit is working, and also how the DC power from the battery is converted to various voltage levels, both DC and AC.
Okay, so Ken, tell us, why do we need this? What is Dory Power looking to offer that people don't have today?
So, I think that everybody recognizes that today the electric infrastructure that's in the United States is aging, and it's been aging much like our roads and bridges. Our electrical infrastructure is not any different. And an electric infrastructure essentially has four main pieces. One is central generation, and these are usually, gas-powered, or in the old days they were coal-fired boilers and turbines and generators. Now, for the most part, they're gas turbines running generators. And these are large-scale facilities that provide generation that needs to get from one place, which is usually very remote from an urban area, to the load center where customers are connecting to the network in order to get power. In order to do that, because they're usually far away, they run through a transmission system infrastructure, which is very, very high voltage. And it's high voltage because that makes it much more efficient to move those electrons from where they're generated to where they need to be consumed. But once they get to close to an urban area or even a rural area, they step down the voltage from high voltage to sort of medium voltage, and now you're in the realm of what's called the distribution network. And the distribution network runs at sort of medium voltages, but then the voltage keeps getting stepped down until it comes to your home or your business. And so at this point, common voltages that we would know as residential customers are 220, 230 volts that you might use to run a well pump or an air conditioner, or 120 that you use to run your refrigerator or your furnace, or very low voltage that you use to charge your cell phone or to charge your laptop. Well, the whole point is that this distribution network, and if you just sort of look around, how does the power get to your home? Well, right now there's a bunch of utility poles and a bunch of wires, and those wires run along the utility poles, and then from those utility poles they come to usually sort of a little substation, and then that substation branches out to your home. Well, when there are storms, what happens? When we had tornadoes or high winds that come along, the electrical utilities, the poles, are extremely vulnerable. Maybe they get hit by lightning or strong winds, they fall over, the lines are severed, or the lines, what happens is they sort of fault. There's a ground fault that causes a short circuit. Instead of the electricity going to you, it goes right into the ground.
All right.
And you get nothing.
So we're talking power outages.
That's correct.
Which we've all dealt with, and you think we're going to be dealing with them more.
I think the number of power outages will increase, not only because of weather, because of aging infrastructure and aging equipment. So until the distribution network becomes next generation technologies, the number of outages that we're going to experience are only going to increase, not decrease.
And some of these outages, I mean, some are hours, but some are days now.
That's correct.
Some are a couple of weeks now.
That's correct.
So what are you offering? What is Dory going to offer that would help us deal with a power outage?
Yeah, so people that want to protect themselves, it's like buying an insurance policy. You hope that you never have to use it, but you buy it to protect yourself when something happens that you need it. And backup power is like an insurance policy. It's the same thing. So for the most part, people very often will go with a stationary generator, which could be either fueled by gasoline, diesel. If it's large enough, it could actually run off of natural gas.
That's the big unit like I have next to the house?
That's correct.
Okay.
And these are much more expensive. They're large. They sit on usually a concrete pad by your home. You don't move them around.
Yeah.
They're connected to your home. And, once a month you may need to start them up, make sure they work.
Yeah.
But you can't run them continuously.
Right.
Because there are environmental protection regulations that limit when backup generators can be used, especially if they run off of fossil fuels.
Okay.
Right? So as an alternative, electric generators have emerged. And these electric generators use battery technology, usually lithium-ion technology. These cells are very efficient, very reliable, and they're very safe. You hear about lithium-ion batteries and potential for fire.
Yeah.
The batteries that we use in the Dory Power electric generators are very, very safe, and that's why that technology was chosen. Now, the idea is that these generators are portable, so you can move them around. Some of them are heavier than others, but they all have wheels, and so you can move them from one location to another location in your house, or you can connect them directly to the electrical panel, either through what we call a manual transfer switch or an automatic transfer switch. With a manual transfer switch, if the power goes down, you just need to go where the unit is and you flip manually the switch that takes you off grid power into Dory electric generator power.
Really?
And it's wired into circuits in your home that are the critical circuits that you want to have powered when there's an outage.
For example?
I would want to have our well pump
Sure.
on a circuit, because when the power goes down, not only is it inconvenient, but I don't have any water.
I would want to have our sump pump.
You'd want to have your sump pump on.
Can it do the refrigerator?
You can do the
kitchen?
refrigerator, you can do the air conditioner if you want. You can use some lights, you don't need them all, just those lights that you think are important. So it's kind of like what happens at the university, as you know, that there are backup generators at Case Western Reserve University. These are diesel backup generators. When power goes down, you don't run all of the buildings. You just run critical loads, and you run critical lighting, and you would do the same at your home. You would determine which loads are critical, which are the most important to have serviced, and then you would make sure that your backup generator, whether you have to switch it over manually or they have what are called automatic transfer switches, they essentially sense the power from the grid, and when you see the power go down on the grid, they automatically flip over and go from grid power to backup power, your Dory Power electric generator, and then when the grid comes back up, they switch back.
So how much of my house could this power, and for how long?
So, I think that it all depends on the loads that you run. If you suppose that you want to run a well pump, your refrigerator, maybe a stovetop, and some lights. Now, the refrigerator, none of these loads are running continuously. They're all sort of intermittent loads. Your refrigerator comes on when it needs to come on to maintain temperature. The well pump comes on when it needs to come on to maintain pressure in the tank. Your sump pump needs to come on whenever it notices the water level is at a place where it needs to get the water out of your house.
Yes.
So these loads that are intermittent, with the Dory Power generator, you can probably run these selected loads for maybe 2 or 3 days.
Wow.
But the nice thing about the Dory Power unit is that we have the capability to charge from solar. So it's got a solar charger in it, and you can get solar panels. If you've already got them on your roof, you can connect them directly into your Dory Power unit, because it has a charging controller called an MPPT controller, or maximum power point tracking, that maximizes the amount of energy that you can get from solar into the Dory unit. So while you are taking power out of the Dory unit, you can be replacing that from solar as long as the sun is shining.
Wow, like forever?
Well, as long as certainly during the day you can charge, and and then either use it the next day or use it over the evening, and then continue to charge as you go through the power outage, as long as the sun is shining.
Wow, it certainly is a versatile generator. And
right.
I can't imagine there's one quite like it right now.
Well, I think that there are competitive products on the market that are similar to Dory Power units. One of the things about the Dory Power unit is that it is one of the only, if not the only, electric power generator that I know that is UL certified, and that also has a US certification for manufacturing and assembly in the US. So currently, with the Dory Power units, you get a 30% IRS tax credit for purchasing a Dory Power unit, at least now through the end of December 2025, at which the current administration has decided they will end that opportunity.
Sure. Ken, let's go back to the beginning. How did this get started? You and your partner, and of course, Chris is an expert in battery technology.
That's correct. So Chris Yuan, who's a faculty member at Case Western Reserve University, sort of started the company in 2017. I knew Chris at that time, but I was not involved in Dory Power when it was starting up. So he had this vision of how do we use this lithium-ion battery technology to help this problem of, backup power, uninterruptible power supplies and backup power. So he founded Dory Power back at that time, and they designed the first generation of these units, and got them on the market. I met Chris when he came to Case, and we collaborated on a number of proposals and sort of research topics. And so Chris and I worked together a lot, but never directly with Dory Power. And then in 2022, when I decided to retire from Case, Chris asked me would I be interested in helping him move Dory Power forward from where they were. He wanted to now look at how could he scale up and what were technology opportunities for not only where are the units now, but what would happen to them in the future. So that's how I got here.
That's excellent. And tell us a little bit about the engineering. I know that there's some, you have some patents on the technology.
Mm-hmm.
Is there something you do that would you say advance the field?
Yeah, I think that, lithium-ion battery chemistries, I think, are very well-established technologies. And there are families of these sort of battery chemistries. The LFP technology are what are used in the Dory Power units. And one of the things that's important, these are small cells that are hooked in series and in parallel to create battery packs. And these battery packs then run at what we call a stack voltage, that is a DC voltage, that is the voltage that this battery stack can produce. The technology that's in the Dory Power units has smart battery management system that manages not only the charging and discharging of the overall battery pack, but it tries to manage how the individual cells are charged and discharged in order to equalize the state of charge across them and maintain the health of the unit themselves.
Interesting.
The other part of it is that the battery pack is a DC source, direct current. But your lights in your home are alternating current. That means that you need to take the DC current at whatever that voltage is, whatever that stack voltage is, and you need to convert it to an alternating current source. The process of doing that is what's called an inverter. It takes this DC voltage and converts it to an AC voltage. And in doing so, it uses sort of high frequency switching technology on the inverter side, but you need to manage that inverter very, very carefully because of the fact that you want to make sure that the sine wave that comes out for your alternating current is a pure sine wave, that is, doesn't have all kinds of unwanted harmonics at 180 hertz or other frequencies that can damage sensitive electronic equipment.
So there's a lot of innovation in that smart battery management system
That's
you're
correct.
talking about. And we should tell our viewers, this was your expertise at the Case School of Engineering.
Correct.
Ken would research and manage smart power systems.
That's correct.
And here you are, talking about practical application.
That's correct.
This must be exciting for you.
It is. That's why, when Chris said, would I be interested in helping Dory Power, and I got some understanding of the technology, the current state of that technology, and Chris and I and the rest of the principals and engineers at Dory Power are putting together a technology roadmap for how this technology will grow and develop in the future. And I think that the flexibility of this technology, because it's portable, is extremely, extremely interesting.
And obviously you have a product.
Yep.
How many have you made? How many have you sold?
So, I think that right now we're selling probably 100 or so annually. So it's not a large amount. These are all built and assembled here in the Euclid facility. And, a number of suppliers that provide the components, the battery cells, the electronics, the casing, the housing, and then these are all assembled here, tested here, and then drop shipped from here.
And we should point out this is a huge facility.
It
We're going to
is.
show you some of it, but we're talking 40,000 square feet
Exactly,
here.
right.
What do you envision for this place?
So I think the major thing that's envisioned here is to be an assembly shop where the units right now, where this is all hand assembled at the current moment, we're looking at, sort of walking before we run. So another area that I worked in for many, many years was automation. So we're looking at how we do sort of soft automation at this point. What are the ways in which we can automate the current assembly of these units, not to make them fully automated, but semi-automated in terms of their assembly. And that's sort of the first step that will be done. And we've got a nice assembly area where that can happen. We have loading docks where we can get large amounts of equipment in, large room for inventory. We currently hold inventory. We have inventory here right now for manufacturing the next 500 units, which we're looking to manufacture before the end of the year. So we're looking at how we're going to sort of be able to get those in. We're really trying to ramp up now on the sales and marketing side to take the inventory that we have and get that out before the end of 2025. We've got a large testing area because part of what we need to do here on the sort of technology roadmap is to generate sort of the next technology, not only for the units themselves, but how these units are going to be integrated both into the home and how they might be transactive units relative to the grid, which I think is where I think the future is headed. And then Chris has a vision for actually building a battery manufacturing plant here in Ohio, and also using some of the patented recycling technology that Chris has been developing at Case Western Reserve University, and has some patented technologies for actually developing a recycling facility that would be a partner to the battery manufacturing plant.
All right. So there's a lot to come. How much is one of these babies?
It all depends on the unit. They run somewhere around between $8,000 and $9,000. That's before the tax credit, which is 30%.
Okay, so it's not cheap, and I'm not going to see it at Home Depot yet or Lowe's or I get through Dory Power.
No. That's one of the things I think that we're working on, is working with distributors like Ace Hardware, companies, rental companies, which I think provide an opportunity. We do sell through Amazon, so you can buy the product on Amazon.
Excellent. Well, I know we're going to be hearing a lot more about Dory Power, and congratulations, Ken, on your new venture. And I think we're going to end there, and we want to thank you for tuning in to another episode of We Are Case, where we bring you change agents from the Case School of Engineering.
And that concludes this episode of We Are Case. Thank you for listening. You can find more stories about the Case innovators who are helping shape the future on our website, casealumni.org, where you will be able to find all episodes of this podcast. We hope you tune in next time for another episode of We Are Case. In the meantime, keep thinking beyond the possible.